let's go ahead and finish up this tangent line business for just a second. So if I want to know what that tangent line actually is, well, I could do something called point slope form. I'm going to recommend this. Actually, let's go ahead and box this off a little bit here. Cool. Point slope form looks like this. If I have m equals 2, and I have a point, 1, 1 in this case, if I have a slope and a point, then I can actually tell you what the line is, or an equation for the line. So the point slope form of my line is going to be y minus y1 equals m times x minus x1. Okay, so in this particular case, it's y minus 1 is equal to m, but we know our m is going to be equal to 2 times x minus 2. Super handy. This right here, this is going to be, that's my tangent line. So I actually want to know it. I actually know everything I need to know to find it. Once I get that m, I have that point. It's the one it goes through. So that point slope form is going to be super handy for us in this class. Lots of people forget it. As opposed to what you probably learned, y equals mx plus b. That's called slope intercept form. So this is point slope form. Feel free to use it. I don't need you to simplify this if it's on a quiz. This is a great form for a line, unless you need to do something else with it. So we, in general, like things that are true. This is true. There's plenty of simplifying in calculus without trying to rewrite something in a different way when you don't need to. We're going to need tangent lines and their slopes. In order to get them, we need to make this whole thing up here more rigorous. This moving closer and closer by my x values. How do I really know what's there? And so the other thing that we're going to need in the next sections is something called a limit. In the future, and I mean the very near future, we're going to need a limit. Okay. And so what this limit is going to say is, well, what was our slope formula before? We had some x squared minus 1. Okay. And that was the change in our y values. We had some change in our x values, right? Because the point we're going closer and closer to, or the other point on our secant line, was 1, 1. So what we want to say is, hey, what happens as x? What happens when x goes to 1? What happens when I get really, really close to 1, but I can't plug it in, right? This is the slope of my secant line, but if I plug in a 1, well, the denominator is 0 and I'm in trouble. So what happens when I get really, really, really close and I make that table, okay, but I don't actually plug in 1? Does anything nice happen? And so this lim here, this little thing on the left, is going to be this thing called a limit. And in this case, the answer is that that limit is equal to 2. And we're going to have lots of nice ways of finding that exactly and computing that without having to do tables. Sometimes in math, we do use tables. Sometimes really it'd be a computer doing lots of tables underneath the hood, and it's a surprisingly interesting and useful thing to do, is these approximations. But mainly in this class, we're going to use these limits as a beautiful language for talking about infinities and infinitesimals, and they show up in all kinds of fields. It really is a breakthrough in how we think about things so that we don't get stuck in these paradoxes of Zeno. We have real ways of talking with each other in a rigorous fashion. And so limits is really where we're going to live for the first part of this class, so that we get this nice foundation to talk about infinities. And after that, the next 2/3 of the class is going to be how do we take derivatives quickly, followed by how do we use them to do cool stuff. Okay, that's really it. So just the quickest of recaps. So we had our average velocity is what we started with. Okay. This got generalized to average rate of change. And then this became the slope of a secant line. Okay, this is a nice geometric connection. But when we wanted to talk about instantaneous things, my instantaneous velocity This was also my instantaneous rate of change. It's a little more general if you're not talking about things like speed. And that was the slope of my tangent line. And this is usually going to take a little bit more work to find out than just plugging in. But the slope of the tangent line is also going to be known as the derivative. And that is what a lot of Calc 1 is about. Calc 2 is about undoing derivatives for something called an integral. Okay, hopefully there was some stuff for you to work on in there, and a lot of big ideas that you should totally spend some time thinking about. Seeing if you can come up with other paradoxes and how we might try to resolve them. All right, that's it. Study lots. I'll see you all again soon.